You can do it if you believe you can. Hi, everyone. In this video, I would like to show you the following major topics. Number one, state the domain and range. Number two, graph a function f of x plus transformations. Number three, given a function f of x, write the equation of the following transformations. And last but not least, number four, for each of the following, find the equation of the inverse. As always, before we begin, I would like to invite you to the following framework. Case one, put a check mark next to any examples that you understand perfectly. Number two, if you're totally lost and you're not sure how to do a certain example yet, put an X next to it as a reminder to go back and practice again. And of course, case number three, you can put a question mark if you're somewhere in between. Let's begin. Number one, state the domain and range for each of the following relations. So be mindful, anything you can graph, anything that we can give you in the form of an equation, they're all relations, but not all relations will be a function. And of course, every function will be a relation. In the first case, you're given the following: negative 2, 4, 0, 1, negative 2, 3, and 1, 0. And of course, if you think about the domain, you can list all the x values. So if you look at this carefully, there's negative 2, 0, negative 2, and 1. So the possible x values are negative 2, 0, and 1. Notice we don't need to write negative 2 twice. Domain means what are the possible x values. It doesn't mean what are all the x values. If you think about the range, those are the possible y values. I'll draw an arrow for you. So looking at the y component, and we have 4, 1, 3, and 0. Again, I like to put them in sequence. You don't really have to. If you wrote down 4, 1, 3, 0, that's fine, but I'm going to write down 0, 1, 3, and 4, just like that. 1b, y equal to x squared plus 2. Again, if you think about the domain, it's asking you for all the possible x values. X is an element of real numbers. If you think about the range, they're asking you for the possible y values, and of course, y is an element of real numbers. However, y must be greater than or equal to 2. Now, sometimes you look at this and say, I kind of get it, but how do I know for sure I'm doing it right? So I'm going to invite everyone to double check. Double check means, can you activate that dual mindset? If we do this algebraically and graphically, do they match? So let me start with the second part right here. If I think about y equal to x squared plus 2, by the way, it's basically going to be a function that opens up with a minimum at 0, 2. So notice by graphing this, you can quickly see that, yes, x can be an element of real numbers, and yes, y could be anything as long as it's greater than or equal to 2. Before I do 1c, again, I'm going to hop back to 1a. Again, same idea, right? If you think about negative 2, 4, there's negative 2, 4, 0, 1. Negative 2, 3, 1, and 0. So again, by graphing these 4 points, you can see the 4 possible x values. And one moment here. Let me just take a step back. Made a mistake, of course. Let's try again. Negative 2, 4, 0, 1, negative 2, 3, and 1, 0. There we go. So again, just by looking at the graph, you can tell there are 3 possible x values. There are 4 possible y values. So this is how you double check. 1c, y equals to the square root of x minus 2. So again, not to overstate this, if you want to start with the graph, fantastic. Very often I'll start with step 1, draw the graph. So when you think about y equal to the square root of x minus 2, this means I start with 0, negative 2. So think about the root x function, but you're going down by 2. Then the next point is going to be here. The next one's going to be, roughly speaking, somewhere there. So the graph looks like that. Again, once you graph this, the domain and range becomes very clear, because if you go back, the domain, which means all the possible x values, x could be an element of real numbers such that x must be greater than or equal to 0, which is in agreement with the graph. Likewise, if you think about the range, all the possible y values, y is an element of real numbers such that y must be greater than or equal to negative 2. So again, if the graph is adding value to your understanding, draw the graph. 1D, y equals to 1 divided by x. Again, in a similar fashion, if I start with the graph, you can draw the following. So I'll grab a different color. By inspection, x cannot be 0 because that would make the fraction undefined. Anything that is non-zero divided by 0 in the world of math, that's undefined. And there's also a horizontal asymptote at y equal to 0. Now, in case you're thinking, I still don't know how to graph this, what can I do? Plug in two numbers. Plug in x to be 1. 1 divided by 1 is 1, so this would give you this part of the graph. On the other side, if you plug in -1, 1 divided by -1 is -1. So again, very quickly, it will give you a nice sketch of the graph. Again, by no means is this a perfect graph, but it's good enough for the demonstration of 1D. Domain, what are the possible x values? X can be anything except for the vertical asymptote. So x cannot be 0, where x is an element of real numbers. If you think about the range, y could be anything. So y is an element of real numbers such that y cannot be 0. So again, once you draw the graph, you can double check both domain and range. 2a, graph the following functions, clearly label each function. Y equals to the square root of x plus 4 minus 3. Now, normally you can create a TOV, table of values, and compose all the xy values accordingly. What we can also do is look at the actual function. See, if you can rewrite this as a sentence, or if you can say this as a sentence, then you can graph this for sure. If you go from left to right, x plus 4 inside the square root means horizontal translation 4 units to the left, or you can say 4 units to the left. If you look at the second part, the -3 is at the end. This really means vertical translation 3 units down or 3 units down. So if you say this in one sentence, you can take the original graph, go left by 4, down by 3. So I'm going to go left by 4, down by 3. There we go. Label this -4, -3. Now, what happens if you want to graph the next point? You can plug in, for example, x equals to -3. Here comes a little bit of mental math. -3 plus 4 is 1. The square root of 1 is 1. 1 minus 3 is -2. There we go. -3, -2. Now, if I jump over to the y-intercept, look what happens. The y-intercept means x is going to be 0. When x is 0, you have the square root of 4, which is 2. 2 minus 3 is -1, right there. So 3 points would be suffice to graph this. So it's going to look, roughly speaking, something like that. And it does say clearly label each function. So we did label the 3 points. I'm also going to write down y equals to the square root of x minus 4 minus 3. 2b, y equals to negative. So notice I added a negative at the front. Let me just make this more obvious. Open bracket, x minus 3, close bracket square plus 4. I would like you to pause the video, try this, and when you're done and you press play again, I'll be here. Welcome back. So for 1b, or I should say for 2b, the first step is to understand the vertex. So for example, does this open up? Does it open down? Where's the vertex? So right off the bat, you can write down opens down because there's a negative sign. So that tells you it's going to open down. If you think about opening down, it's also going to signal to you you're thinking about a maximum. So before we begin, you know it's going to open down. There's going to be a maximum. The next question becomes, where is this maximum? So for example, if you look at x minus 3, you're going right by 3. Technically, it's horizontal translation, 3 units right. Or you can say right by 3. Likewise, the plus 4 means vertical translation 4 units up or 4 units up. So again, in one sentence, you can say the vertex is going to be a 3, 4. So I'm going to go back. Let me erase this part. But I will label this point, which is really the maximum, located at 3, 4. Now, there's something called the step pattern. And again, there are many ways of doing this. But the step pattern means if you go left by 1, you can go down by 1. If you go right by 1, you can go down by 1. Again, you can label these points 2, 3, and 4, 3, respectively. If you go left again, you're going to go down by 3 this time. And again, technically, there's another one there. And this point's going to be 1, 0. This other point, maybe I'll put it in here. That's going to be 5, 0. Now, what about the y-intercept? To find the y-intercept, there are two ways of doing this. One method is you can plug in x to be 0. If you do, watch what happens. -3 squared is 9, times -1 is -9. -9 plus 4 is -5, which is going to be somewhere beyond the scope of the graph. But you can connect them like that, draw an arrow. The arrow just means the graph continues, and it continues forever. And again, label y equal to negative x minus 3, quantity square plus 4. So again, not to overstate this, when it says clearly label each function, what are we looking for? You have the points, you label the points just like that. And of course, ideally, you want to maximize the graph and you want to label as many features as possible. 2C, again, graph the following functions, clearly label each function. Y equals to 1 divided by x plus 1 minus 3. If you start from left all the way to the right, this really means horizontal translation 1 unit to the left. This means vertical translation 3 units down. In one sentence, you can say go left by 1, down by 3. Now be very mindful. What does that really mean? In the original function, there's a vertical asymptote. So the original function has a vertical asymptote at x equal to 0. Not anymore. This means you have to move that vertical asymptote left by 1. On the new function, you go to -1. You can draw this vertical asymptote, x equals to -1, just like that. Likewise, in the original function, there's this horizontal asymptote at y equal to 0. But in the new function, the -3 means you have to go down by 3. So you move this exactly 3 units down. So y equals to -3. Now, what about the rest of the graph? Well, you can pick different points. For example, you can find the intercepts. Let's say you're finding the y-intercept. When x is 0, that's 1 minus 3, which is -2, right there. So you can label the point 0, -2. Now, if you want to find the x-intercept, you could, but this is going to give you a decimal, right? So you could do that for sure, but I'm going to tell you right now, it's going to look, roughly speaking, something like that. If you really want to know what this point is, then I'll show you right now. To find the x-intercept, you're going to set y to be 0. So if you want to label that point, what you would do is bring the -3 to the left-hand side. 3 equals to 1 divided by x plus 1. Now, you can cross multiply. You can also flip both fractions, by the way. If you take the reciprocal of both sides, 1 over 3 equals to x plus 1. X equals to 1 over 3 minus 1, which is -2 over 3. So if you want to be very clear, then this point is going to be -2 over 3, comma 0. Now, what about the other side of the graph? Again, you can pick a point. For example, you can plug in -2. When you plug -2 in here, 1 divided by -2 plus 1, that's -1, minus 3, that's -4. You can grab a calculator. I invite you to use mental math. But basically, there's a point at -2, -4. And again, the rest of the graph would look, roughly speaking, something like that. You can draw an arrow to show that it keeps going. 2D. Again, I would like you to try this first. You can pause the video. When you press play again, I'll be here. Welcome back. 2D is one of those questions where I would like to remind everyone, in case you forgot, to write down this very, very important step called factoring. Do not go straight into graphing yet. Make sure you put this in factor form. Once you have it in factor form, then you can graph it. So what I mean in this case is you want to factor the 3 to the front. In the brackets, it's going to be x minus 2. Everything else you can copy. Now, there's a lot going on here, and you need to know what this really means. So the first thing I would say is figure out the starting point. So for example, if you think about the transformations, the x minus 2 means you go right by 2, or horizontal translation 2 units to the right. The plus 1 means you go up by 1, or vertical translation 1 unit up. So again, in one sentence, this means one of the points is going to be located at 2, 1. So go right by 2, up by 1. There we go. Label this. Now, of course, you need to know the next point. So this is where, if you want to grab a calculator, you could. And I'll grab a calculator and try this with you. if you plug in, let's say 3, now we're going to get a decimal, and that's totally fine. So imagine you plug in 3 in this case. So what happens is you write down in your calculator, you can type it in, the square root of 3 times 3 minus 6. You press equal, then you're going to add 1. I'm going to do this with you right now. So again, the first step is I take 3. So that's going to be 3 times 3, that's going to be 9. Minus 6, that's going to be 3. When I take the square root of 3, that's going to be 1.73. I'm adding 1 to it. So I get 2.7320508075688877, or roughly 2.7. So what do? I go right by 3. I go up by 2.7. It's totally okay to label the point with 3, 2.7. That's a key feature. I'm going to do this again. Are you ready? I'm going to plug in 4 this time. I'm going to grab the calculator. I'm going to press 3 times 4, which is going to be 12, minus 6. That's going to be 6. I take the square root of 6, which is 2.4495 approximately, and I'm adding 1. So now I see 3.4494897427838178, or approximately 3.4. I go right by 4. I go up by 3.4. So let's graph this for you. Of course, as I'm graphing this, I recognize I made a mistake. 2.7 is not there. 2.7 is actually right there. There we go. That makes more sense. So there's a bit of double checking as I'm doing this. So again, 4, comma, 3.4. And if I connect them, I draw the arrow. But again, what do we mean by clearly label each function? Let's be very clear about that. You have these points. You label them. You have, for example, in this case, the vertical, horizontal asymptotes. When you do all this, you're now earning all the marks. 3a, given the following, graph y equal to f of x minus 2 in brackets plus 1. So again, the first step is you have to know the mapping rule. And once you have the mapping rule, then we're going to list all these points. So for example, in this function, we have negative 4, 2. We have negative 3, negative 2. We have 1, negative 2, 3, 1, 4, 1, and 5, 0. So we're going to take these original points and we're going to go through the actual mapping rule. Now I'm going to switch colors so you can see the graph is going to be in a different color. Even in one sentence, I hope you can see this means take all those points, go right by 2, up by 1. That is kind of the executive summary. Technically speaking, if you go right by 2, that's x plus 2 in the mapping rule. If you're going to go up by 1, that's going to be y plus 1. So I'm now going to take all those points, those original points, and I'm going to go through the transformation. So again, if I take all the x components and I'm adding 2, here comes the mental math. Negative 4 plus 2, negative 2. Negative 3 plus 2, negative 1. 1 plus 2, that's going to be 3. 3 plus 2 is going to be 5. 4 plus 2 is going to be 6. 5 plus 2 is going to be 7. Likewise, I look at the y components. I'm adding 1 to it. Are you ready? 2 plus 1 is going to be 3. Negative 2 plus 1 is negative 1. Negative 2 plus 1 is negative 1. 1 plus 1 is 2. 1 plus 1 is 2. 0 plus 1 is 1. The hard part is now over. I go to the graph and I label these points. So I go negative 2, positive 3. I'm even going to label this. Really spend that time to do your best and forget the rest. Negative 1 is here. 3, negative 1 is going to be here. 5, 2 is going to be here. 6, 2 is going to be here. And of course, 7, 1 is going to be right there. And now you have to connect them with a straight line. So it will look something like this. Let's use a thicker line for you. Let's try again with a thicker line so you can see kind of how this all connects. Just like that. So again, in one sentence, imagine the graph in blue. I move the entire graph right by 2, up by 1. That's the new graph. And of course, don't forget to label this. So this entire graph is going to be f of x minus 2 plus 1. 3b, given the following graph, or given the following, graph y equals to negative 0.5 times f of x. Again, I would invite you to pause the video, try this all by yourself. When you press play again, I'll be here. Welcome back, everybody. Here's the first step. You're going to write down the mapping rule. You're going to write down the original points. For example, negative 5, 2, negative 3, negative 1, 1, 0, 3, 3, 5, 0. Once we write down the mapping rule, we're going to go through each coordinate and find the new coordinate respectively. So again, go from left to right. That's the best sequence. If you're not sure how to navigate with these transformations, start from the left, go all the way to the right. Another framework, of course, it's really step 1, reflect it, step 2, stretch it, step 3, move it. To avoid the paradox of choice, we're going to stick with start from left all the way to the right. Let me grab a different color. This negative sign in words in a sentence means reflection or reflected with respect to the x-axis. So that means you have negative y. Look at the 0.5. Again, in a sentence, that's a vertical compression by a factor of half, or you put a half in front of y. So notice x doesn't change. So I'm going to copy negative 5, negative 3, 1, 3, and 5. Those are the same points. When I look at the y values, again, I'm taking all those numbers. I'm going to multiply by negative half, or you can say divide by negative 2. 2 times negative half, that's negative 1. Negative 1 times negative half is half. 0 times negative half is 0. 3 times negative half is negative 3 over 2. 0 times negative half is going to be 0. Now, for those who are watching this and you're thinking, I don't want to write down half. Can I write down 0.5? I don't want to write down negative 3 over 2. Can I write down negative 1.5? Absolutely. But I am going to say this. If you have 1 over 3, don't write down 0.3. You really want to leave an exact form whenever possible. So again, the hard part's now over. I go back to the graph. Negative 5, negative 1 is going to be right there. I'm going to label this point. Negative 3 half is going to be right there. I'm going to label that point. Next, we have 1, 0, which is known as the invariant point. We'll come back to this at the end. The next one's going to be 3, negative 1.5. And last but not least, 5, 0, which again is another invariant point. So I'm going to take a straight line. I'm going to connect them first. Now, the question did not ask for invariant points, but we're going to show you. So invariant points are the points that doesn't change. So if you look at the points from before and the points after, they're the same. So those are called invariant points. And in this case, the invariant points are 5, 0, and the other one's going to be 1, 0, respectively. All the other points are different. Example number 4, given f of x equals to x plus 7, write the equation with the following transformations. Reflected with respect to the x-axis, vertically compressed by a factor of 1 over 3, horizontal translation 2 units left. Step 1. Again, you want to write something that's new. So the O function is f of x, which equals to x plus 7. And now you have to look at this and say, how can I rewrite this in terms of f of x? Let's build this one step at a time. So in the first case, when it's reflected with respect to the x-axis, this is negative f of x. So this is negative f of x. Now we're going to update this, by the way. So as we're doing this, we'll erase a little bit, write down the new update, and so on. The next part says vertically compressed by a factor of 1 over 3. So we have to put 1 over 3 in front of f of x. So notice I'm erasing this. I'm updating it just like that. Now for some students, you can leave a space, which is fine. Or you can update it the way I'm demonstrating it in the video. And of course, horizontal translation 2 units to the left. Now here's a mistake. Are you ready? Be very careful. This is not it. If you think horizontal translation 2 units left means x minus 2, that is incorrect. The correct answer is f of x plus 2. So again, think opposite when it comes to horizontal translation. Now, you're going to take this function. I'll use a different color for you, f of x. You're going to apply it, right? So whatever we give you, like if you really look at it, whatever we give you here, you're going to plug it into here. And I'll put a big bracket here so you can see the two separate thoughts. The first idea is you copy negative 1 over 3. You're going to have a big bracket. F of x plus 2 just means instead of x, you replace it with x plus 2. So again, let's be very clear. This x plus 2 came from this x plus 2, which you're going to plug in. The plus 7 you're copying, right? I'm even going to use the same color just to show you this is the part you copy. Let me go back to the previous color. So really, like if you look at it, this is negative 1 over 3 in brackets x plus 9. If you expand that, the new function, which again is going to be negative 1 over 3 times x. Oops, let's try this again better for you. Negative 1 over 3. Let's try this better because I don't want you to miss the key concept here. Let's try this again. Okay. So when expand this, it'll be negative 1 over 3 times x. Negative 1 over 3 times 9 is going to be negative 3. And that is the new equation after you have those transformations. I'm not double checking this one, but I'm inviting you, if you want to draw a graph of f of x, draw the new graph with the transformations, you will see how this all makes sense. 5a, for each of the following, find the equation of the inverse. So again, you're given a function, f of x, which equals to x squared minus 5. Again, there are 3 steps when it comes to finding the inverse, and this is kind of the shorthand. So if you want to find the inverse of a function, I would say the first step is you can swap x and y. You can switch them, you can swap them. Then, of course, the second step is you isolate for y. And the moment you isolate for y, whatever that is the inverse. So let's talk about this and demonstrate it. So first step is I look at y equal to x squared minus 5. I swap this. So x equals to y squared minus 5. That's step 1. Step 2 is I'm going to isolate for y. Now, for some students, they look at this. They like to write down y squared minus 5 on the left. That's fantastic. You can just recopy this, but in reverse sequence. To find y, you have to write down y squared equals to, again, the opposite of subtracting 5 is to add 5. And in a different color, the opposite of squaring something is to find the square root. Again, if this is all you have, this is not the perfect answer yet. When you find the square root, there are 2 cases, plus and minus, just like that. So really, the inverse of f of x is going to be plus or minus square root of x plus 5. Great starter, great finisher. 5b. For each of the following, find the equation of the inverse. Again, please pause the video, try this first. When you press play again, I'll be here. Welcome back. F of x equals to x minus 4 divided by 3. If you like, you can even rewrite this as y equal to x minus 4 divided by 3. So again, the first step, swap x and y. X equals to y minus 4 all over 3. The second step is to isolate for y. And again, you can think of x as x divided by 1. So one approach is you can cross multiply. So 3 times x equals to 1 times y minus 4. If I continue in the next column, 3 times x is 3x. 1 times y minus 4 is y minus 4. Again, if you prefer the y minus 4 on the left, that's perfectly fine. Just rewrite it in this sequence. Once you isolate for y, that becomes the inverse, which is going to be 3x plus 4. I hope this makes sense.